Calling sequence. Compute the arguments and store them in their correct positions in the new activation record. That is, pushing them in order onto the runtime stack. Store or push the FP as the control link in the new activation record. Change the FP so that it points to the beginning of a new activation record. It means FP equals SP. Store the return address in the new activation record. Jump to the code of the procedure to be called. Return sequence. Copy the FP to the SP. Load the control link into the FP. Jump to the return address. Change the SP to pop the arguments. Variable length data. There is a possibility that data may vary, both in the number of data objects and the size of each object. Let's take two examples. The number of arguments in a call may vary from call to call. The size of an array parameter or a local array variable may vary from call to call. The printf function in C, where the number of arguments are determined from the format string that is passed as the first argument. Printf %d, %yes, %c, n, prompt, ch. Printf hello world. C compiler pushes the arguments onto the stack in the reverse order. The first parameter, which tells how many more parameters are, this first parameter is always located at the fixed offset from FP. Local temporaries. Local temporaries are partial results of computations that must be saved across procedure calls. For example, x of I equals I plus j into, that is star, I divided by k plus f of I, semicolon. Three partial results need to be saved: the address of x of I, the sum I plus j, and the quotient I divided by k. They can be stored in the registers as temporaries on the runtime stack prior to the local to F. Nested declarations. Nested declarations can be treated in a similar way to temporary expressions, allocating them on the stack as the block is entered and deleting them on exit.